Hello. I'm just going to wait a few seconds just in case something weird goes on. Yeah, hello. Just as an introduction, this is Boring Ben, which is just a series of where I design stuff live on YouTube, and at the moment every single video is about designing this module. It's going to be open source hardware project because I wanted to run through it, see how the certification works, and with the open source hardware. OSHWA, it's OSHWA, the Open Source Hardware Association. Interestingly, in March, there's a summit coming in London, in the UK, in Edinburgh, I think, which I'd quite like to go to, maybe. Yeah, the open source hardware certification is... I need to read it in detail. Do I have to pay? About... I think it's basically just about standardizing open source hardware and principles around it. I had to become a member, and how do you get oh, it's too much information to do. I'll do this in another video, but at the end I'm going to run through this. At the very end of doing this design, I'm going to run through certifying it for open source hardware, and I also want to try to do some EMC pre-testing just to learn electromagnetic compatibility. But the overall idea of the project is it's going to be a no solder project, so the idea is you can just order it straight from JLC PCB and you just put it together by screwing panels together and bolts and stuff like that, basically. It's based around the Raspberry Pi RP2350 chip, because it's new and I quite enjoy writing little circuit Python scripts and MicroPython scripts, but it's also quite capable of much deeper DSP. It's going to have a programming port, which is USB-C on the front, and a host port, so you can put controllers in it and stuff, and a micro SD card, and it's just got a bunch of CVs in and out. It's kind of, I guess it's a bit like Ornament and Crime Eurorack module, or EuroPie. Anyway, where I'm at is, we've run through a sort of preliminary idea of the schematic. There's lots of little niggling details, like maths, basically, and how things are going to work. Yeah. But I've basically mapped out everything in a way that I think should work, and I'm currently doing the layout. If you look at the 3D, currently doing a layout of this board on the left, which is going to be the main sort of brain section. If you see at the top, there's the RP2350, and then this is all like the op amps and DACs and ADCs, and this ridiculously sized inductor. Might have to rethink that. Yeah, so I'm just going to get on now with I'm going to live up to my name and just go on with the really boring stuff. which is I'm going to try and route everything here. Currently I've routed, it's a 4-layer board and the front's got all the components on it. There's 2 ground planes, one on the front, no, one down. It basically goes signal, ground, and I'm trying to route as much signal inside. I know that's absolutely terrible because if I had to cut any traces, it might be a nightmare. But oh well. But there's stuff you can access on the top if you needed to do some mods. I'm not going to try and split the ground planes with analog and digital ground. Yeah, I'll just get going. I think what I'm going to do now, do I want to try and get the signals out of there? I think that's generally best. There's a bunch of signals here that are trying to leave. What's this? Oh, they're the encoders. Great. I dim it. Right, so there's a load of ground wires that are going to get in our way. Quite want to avoid going inside the chips or via outside. Ah. Is that special? What is this one? It's quite special. But I'm sure I can move it up a little bit like that. They're quite close to each other. Quite often stuff seems quite I also think my clearances are a bit wrong. What I haven't done properly is to find my design rules. It's kind of what you're supposed to do first. So design rules are just like, if you don't know, are rules that the fabricator gives you to tell you how far things should be apart so they're guaranteed to work. And sometimes they will charge you more if you break their design rules, or they just reject it because they can't make that detail fine enough. But the traces, right, are supposed to be on a multi-layer board. 0.9, I'll keep to 0.1. That's what I've got. Track width 0.9. Oh. Minimum track width spacing. No. Minimum track width and spacing. Oh yeah. So it's track width 0.1. Why have I got it as? Why have I got it? It's got to be 0.1. I mean, it could be 0.9 actually. I'll leave it at 0.9. I think I set that. What about pad? Minimum through hole drilling, drill diameter. I'll stay with a 2-layer. It's 0.15. Oh, that's really tiny. the clearance between the holes. Hole to hole spaces for fires. Pad to hole is 0.45. Whoa, it's wider. Pad, hole to hole spacing 0.45. Oh dear. Don't think I've ever set that before. But is that what that is though? Like when I do this, you can see this grey space around it. If I change that to clearance, if I did something ridiculous like 0.01, see it hasn't changed. So what defines, I've always wondered what defines that. GCAD trace clearance grey. Yeah, well, it's not worth watching. That's too much of a rabbit hole, but like, it doesn't seem to change when I change it there. I always used to think it changed it there. Is it in my oh, here it is. So if I made that 0.1, so I guess the design restricted constraints are for the DRC. Ah, there we go. Interesting. I've never really realised that in these settings, constraints is more for the design rule checker. They're the design rules, but the nets have their own clearance. But what about the vias? Oh, I'd love to do some teardrops. Strange. Now, if you look, I also want I want a really stupidly fine grid. I hate that snapping as well. How do I get this? I'm basically going rabbit holing on settings just for a minute. Show grid. Oh, I think that would probably be routing settings. I don't know. I find that way it jumps around really annoying, that's all. Like, see, I'm trying to pull it over here and it's jumping and jumping and jumping. See, our vias still have massive clearance rules. And what's our via? There's a whole section probably to vias, I think. Drilling, traces. Oh no, it isn't. Drilling. I want via clear, via hole to hole spacing 0.2. So is that 0.2? No. Hole to hole clearance. Huh. Thing is holes are never that close, vias are always that close, so I'll just set that to 2. It's funny that you can't have different settings for vias. Does that change the way vias behave when you draw them? No, they've still got massive clearance around them. Why are they still so big? Keycard via clearance. Where can I set the clearance for vias? There are no settings for vias. Same as for tracks and pads, and they all set in design rule net classes. Oh, again, it's in net classes. Oh, yeah. Again. Wait, what? I've got the clearance 0.1. Is that clearance for copper? Don't understand. Oh well. Just keep going. You can faff around with things too long. Am I using my right bias as well? Yeah. It's the smallest. Okay. So these. So I'm going to have to move these along a little bit because ooh, it's annoying, isn't it? I just hate this jumping behaviour. Squish these down. You know what though? There isn't a CAD program out there that has annoying quirks. All CAD software is just about workarounds. So this is the... I'll just make it as small as I can. Why is it so... This is the debug port. I'll just do that, screw it. Oh, look at that beautiful right angle trace it did. Oh yeah, oh, lovely. Oh, we wrapped around the crystal resistor. That's going to be nice when you're debugging and you suddenly interrupt your clock. Oh, come on. Why is the clearance around the wires so massive? Ah, stop jumping around that resistor. Come on, you can move. As you can tell, I'm not up for quirkiness today. This is annoying me. Look at that trace. Why does it want to do that? Be gone! It's so frustrating that this can't come in any. Stay there. Great. Let's just drag that up so it's out of the way. That'll do. Just a simple debug thing. And then now we're going to go into the internal layer. Oh, don't do that. And just, if you press dim, you can see things a little bit clearer. The question is, are these the right way around? It goes Enc 2A, Enc 1B, Enc 2B. Okay. So we want it to go in the same order as the pins here. So it needs to go Enc 2A. So we're going to swap around some pins on the encode pins. So it goes, currently we've got a pin 35, is that 35? Yeah. Enc 2B. Okay. So we need to go Enc 2A first. Enc 1B. No. Maybe not. We've got it going encoder 1 switch, encoder 1A, encoder 1B, encoder 2 switch, encoder 2A, encoder 2B. But for some reason I've got it going 2 switches and then AB. Oh, the other one's over here. So what's this one? Ink 2B micro. Oh, that works. Ink 2B micro. Ink 2A micro. Ink 1B micro. Ink 1A micro. Ink 2 switch. Ink 1 switch. Oh, it is an order. I was confused because there was this one as well. Right, so now we've got problems because these resistors are going to have to get their ground up here to allow for all the traces to come through here. I might keep these quite small. So this is the outer one. Probably don't want to go under the inductor. We'll go through in the top. Made a weird triangle. The trace shapes are so unpleasant sometimes. Wait, that's got a different trace width. I probably should have defined a trace width. See, I still don't understand why they have such huge. Ugh. Now I've accidentally gone through. I might turn shove off for a few minutes. Let's put it on just highlight collisions mode. Because I like shoving, but when you're trying to do something long like this, you do one little move and you end up... Oh no. The switches are at the end here, right? But on my... Right. I don't know why I've done that. I think that's better. So that's the first encoder. So it goes 2 switch, 2A, 2B. Does that go 2A, 2B, to switch? 2B, 2A switch, sorry. Oh, my trace sizes are all over the place. Oh wait, what? Ah. Wait, the second one is correct. There you go. I'm starting from the bottom. Because just drag it right out like that. That's weird. Come on. Oof. Oh, so collision at the bottom. Oh. It would be cool to have berry dryers. But they are expensive and you'd be very prone to problems. Now I'm going to turn shove back on. Which way do I want to shove it? Probably this way. But nice, everything was like keep it compact. Am I setting myself up for a disaster? Probably. So what else needs to just go straight out to the connector? Looks like there's something stuff flying from up here. Oh yeah, user switches. Don't really want to block that. Oh, look at all this 3 volts I'm going to block. Oh no. Probably could be solved by... It's quite chunky here, right? No, I think that's right, the clearance. They don't have a clearance for... It's for traces, isn't it, really? Huh. Minimum track width 0.1. But wait, inner layer via to copper clearance 0.2. That's inner layer. Point 2 is generally good. Maybe I'm going to bite the bullet and wait, switch menu boot. Yeah, that's a switch. That's also going straight out. What? No. Is my menu switch not on the header? Oh no. It's called boot micro. Switch menu boot micro. It's the one that comes out of QSVI SS. It's there. It should also be on the GPIO as well, right? Yeah. That's it defined on the chip. But oh yeah, see, this is where not splitting it makes it confusing. It actually needs to be going through the connector because it's on the front panel. So I need one called jack. I need to make this look clearer in the schematic eventually. I need these to be here. We've got to run. But I think I don't need 3.3 on the front, do I? Because it's a bunch of jacks. the USB connector. This takes in 5 volts. What does it take in? 12 volts. It's probably don't even need the 5 volts. So I don't need the 3 volts on the front panel. Why is it? Oh. Probably want to move ground. There you go. So now I should also want to go to the connector. This has got to be because this also has to connect to I think I might have got that wrong. I'll have to go over that again. Okay, so now, how am I going to get these? Guess I'm going to have to go under the chip. It's a bit naughty. Ooh. And that's not even where I want to go, actually. I'm going to have to switch the HSTX stuff with the switch stuff, which is annoying. So as they are DC, yeah, so what I need to do is I need to take these guys, take these 4, move them down, and these go here. Should work. Menu boot, switch one, user one, user two, DC, chip select, clock, DN, reset, blank. Let's delete all these. Oops. I wonder if I could just shove them across. Nope. Why is it? Annoyingly, it's making more traces. What a mess. You come out of there. It should clean itself up though if I do this. Oh, no it doesn't. Go on, go away. Ugh. What a mess. It's the only problem with these interactive router things, when with incredibly disgusting fragmented tracks. Okay, that looks nicer. Now I've got to, I don't want to touch this area. Apart from this, what's this? I'll leave that off. It would be nice. How do I edit this? Just gotta check something. Just gonna double check the stream. Right. I've got to I think I want to make these traces less chunky. But how do I do that without net? Oh, what did I do there? Why did everything change, but not change? Changing the net will also update 133 connected pads to that. change nets. But it doesn't. Select. Ah, there you go. Right. U. There's a key that I used to use in KiCad that went missing. I think if you used to press D over the top of a trace, it would delete the whole trace. They got rid of that. Okay. Why is shove not working anymore? What? Oh wait, why have I changed them all to... Oh... Changing the net will also update 133 connected pads to that. Leave nets unchanged. I don't understand that. I need to read more into... Oops, I just didn't select the whole thing. Because surely those are different nets. Why is it treating them all as the same net? I don't understand, because if I write net this one, change to this, press OK, why is it saying change nets? There's 133 connected pads. I don't understand. So now it's not changed the nets. Great. Let's try and straighten these all out. God, it's disgusting. Whoa. Oh. Nice clean lines. These are basically this is a high-speed line. Theoretically, might be a high-speed SPI bus. Not that fast though. Not fast that you have to start worrying about transmission lines and all that stuff. If it was a HDMI output, which this interface apparently can do, it might be a problem. So I've got this big sort of right, I have to turn off shove again because it's just to highlight collisions, don't shove things. Stupid wires. Oh, these are all in different order too. So this goes menu boot, run user 1, user 2. Menu boot, run is somewhere else. User 2, user 1. That's probably a problem on the micro. Yeah. And what have I got? I've got it on the left. It's boot. It's boot. Down here, boot is the one on the right. Which, so we want to go boot user 1, user 2. These are all just general purpose, so. So has that fixed it? Goes user 2, user 1, run boot. No. User 2, user 1, boot. We want user 2, user 1, boot. So it needs to just be the other way around. So now it's got boot on the left. Down here it's boot on the left. The other way around. That's how I had it. Boot on the left. Boot on the right. Oh, maybe I was reading. It's not changing. I've got boot on pin 28. I want boot. On 26. Okay, so that was right. There we go, that should work now. Just delete that. Learned a new key today. Pressing U selects the whole trace. What am I colliding with? Ugh. These should be quite harmless signals because they are open collector switches. Well, not collector, open switches mainly. Although I guess they're prone to getting interfered with. So a signal could probably create a false positive. Where's the run pin? The run pin is pin 35. Where's 35? 60, 40. Oh, it's up here still. Oh, I've got it. Oh no. This is where I might have to use shove. Root. Shove. Ugh. The mess I'm making. Oh no, and I'm in the wrong place. Doesn't matter. Oh, don't go around there. Oh, you. Oh, don't go around there. It went back on itself. intelligent routing is a pain. No, no, no. See, it's funny that it can't just shove that out the way. Especially these vias with their ridiculously massive clearance. Really, I should swap these around, but I just can't be bothered. Right, now I'm going to go and try and clear up this a little bit, because look at this. Be nice to have a little bit of clearance between well, what's this one? User button. They're all kind of the same thing. It's switches. It'd be better if they were away from the high speed. These are all kind of the same thing. They're all the encoders are like switches too. Get rid of this ugly corner. Not that way. How do I stop this happening? Yeah. Okay. Now, is there anything else coming straight from the chip to the connector? I don't think so. So I'm an hour in. I've only really done my digital signals coming out to the connector. Now it's time. What I'm hoping is now, might just dim it, I can connect a lot of this stuff on the top. Yeah, just like this. Wait a minute. These would be better. Below. I should be really doing these resistors on some kind of grid. Makes a lot more sense. Thought that was connected to that. I almost don't even know what I'm connecting. That seems to break the pattern. These. Strange. Oh yeah, because it's that configuration. Wait, I'll just go to this first. What? Why did all of the... Oh yeah, because it's got two... There's 1, 2, 3, 4 components. Yeah, that's all of those components. And now I've blocked that. Could I just be sneaky and do that? It's the same. What was it? These two. Sneaky. Go somewhere else. What? Oh, it's a voltage reference. That goes like that. That goes like that. That goes there. These know each other. These connect to each other. Oops. Yeah, they all follow the same pattern, which is good. I'll go through and connect any grounds. Wait, that is for minus 12 of what? U11. That's not U11. What's... Is U11 this one? Yeah. This one was meant to be over here. Where's this other one? Huh? Okay, I was going through do some grounds. Quite good to see everything. As you can see, my big buses of underneath, so I can avoid them. Ground. Ground. Ah. I'll be naughty there. Why is this one so... Oh, it's a power supply. I don't think there's any more to come through here, so I think I'm safe connecting to there. So everywhere there's a ground, I'm just connecting it straight through into the ground plane basically. Oh, there's some more routing here. Ah, that one's wrong. Come on. Ah. This one and this one need to be swapped. See that when you're working on a PCB, you can sometimes just be working. You don't actually know completely what you're working on. Like you work on things in a sort of micro scale. Though why is that one got? Oh yeah, it's the duck. Having a ground plane though is great because you always know that you've basically got this just grid of ground behind you. You can always just connect downwards into ground. You're supposed to try and give everything its own separate ground connection. There's a load of stuff here. These are comparators. They seem a bit spaced out. To give more space in the middle, because I'm thinking of putting a connector in the middle here. I'm going to pull them out here, maybe put them in a line with this. This is for U19. Is this U19? Yeah. I mean, it seems a waste, actually, because I've got move these slightly closer to each other. So now those are a bit far away. Surely it's better if I just compress these together like this. And these connect together nicely. Wait. it's just much more of the boring repetition. This big cap to try and keep the reference stable. What's this one? It's an op amp. U6. Oh, it's the audio input. Op amp. Oh, and this is all the stuff that goes in. Probably going to stop in about 10 minutes, but just going to check. Something. So where are we? The line's getting less, but there's still quite a lot. Easy win is to get with grounds in. Now I think I'll start routing these. So they're the inputs. Audio input 1. They're CV outs. Oh yeah. These are the CV outs. Alright. So it's in the wrong order. It should probably go like that. Oof. Okay, so these have got to go to... This might be a case of having to move everything around. Those have got to go there. Those have got to go there. Higher and higher. Really, this one should be the top left one. So I guess, how can I swap those around? I need the one that's currently going to U17 coming, U17's going to. On the right hand side, so that's the 8-pin, 7. This one should be going I'd rather it be going here. How would that update? No, that still wants to go right. Yeah. I want to swap the odd panels. So, wait. No, but that changes all the associations. It's probably best to change it on the connector instead. Yeah, that'd be easier. So I want that one to be over here. I want that one to be the furthest right. I want this one to be the second left. This one to be the second right. So on the connector, I want it to go, instead of 1, 2, 3, 4, it needs to go to 2, 4, 3, 2, 4, 3, 1. Yeah, that works. I might just have to rename later on. Two, 4, 3, 1. That just makes the routing clearer, you see. So now, oops. We can get this to go up here. This to go here. This. This could be a problem. And this, also a problem. Because I don't have my routing unless I need to shove over I have all my resistors sitting here. I just need to shove these over. Don't think it's a problem. Doesn't have to be right over, it could be to there. Actually this could go through all the resistors, but let's not do that. Well, let's do that. No, let's not do that. Keep it a little bit away from the... So this wants to go up here. And this only wants to go like here. And then these, this one wants to go here, this one wants to go here, that's all of them. Should I try and do the gates as well? Gates are here. I haven't done anything with the gates actually. Wait. Connecting up all the power. Right. They want to go to there and that. What? No, that's wrong. What are these for? These are CVNs. That's USB. I don't want to mess with that at all. Oh. component is this? Oh, this doesn't have a place yet. I should just put that there. Is that the other one? Yeah. And this is the protection diode. It's quite hard to visualise what's going on here. It looks like that basically. This bit here. Wait, I've got them the wrong way around. Just do that. Oh, no. Let me think about this. This doesn't have to be here. Wait, this? Oh, that connects. What if it was like that way around? That one would connect down like that. This can just go round. That will go up like that. Okay. Oh, it might be quite good to connect the I squared C bus. It's got quite a long way to go. Unfortunately, I can't. Well, I can't really choose where it goes. I guess it should come between. Not many wires, so I could get those to do that. Just SDA. It's just 2 wires. Don't want to block those 3-volt rails. Chunky. See, why doesn't that complain? That's strange. Oh. Oh yeah. It's probably best if it comes down. But it's still going to get blocked on the top layer. That doesn't have to be there. I can break into a third layer if I want to. Screw it, I'll go here. It's a bit strange because my clock is going one way and my date is going another. And now my clock is bridging across power, but then it has earth and it has ground in between. Because it will be this layer, a whole sheet of ground, and then that on top. So that's connected, and then I want my I need my 4 outputs to get to these op amps. There. 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 Oh, what a mess. Oh, I'll think about that another time. What's low hanging fruit? What is that random resistor? Oh yeah, one that I missed off. These are CV in and those are CV outs. How does the CV outs? CV in, I've done the CV outs. How do the CV ins? How are they going to get down? They're in a weird place, aren't they? CV out, CV out. Oh god, are they over the other side of the... Audio. They're over this side. But in my design I've got audio op amp, for some reason I seem to have these on the wrong side. They're going to have to come right across. Might be okay. Are they even conveniently placed near the ADCs? Yeah, they are. That's one advantage. I'm not sure how I'm going to get down there though, because Right, I think that's enough for today. I thought I was going to do more, but it's looking okay. There's quite a bit of rat's nest left. Yeah, there's little blue lines. These are very fine traces. The gap between them is 0.1, but that's the pad to track. Inner layer holds copper as 2. Multi-layer, the spacing is 0.9. But I'm doing 0.1, so in theory that's right, that's fine. Anyway, thanks for watching. Bye.